Okay, so on number 6, now we're dividing two numbers in scientific notation, right? So how do we do it? Well, you can probably guess. You begin by dividing the numbers in the front. 8.05. We don't need these zeros at the back. I don't know why they did that. 8.05 divided by 3.5. So just divide the numbers in the front on your calculator. I'm getting 2.3. So 2.3. So that's the first part of the answer. 2.3 times 10 to some power. Notice that decimal is in the right spot, so we don't have to fiddle with it. It's right where it belongs for scientific notation. It's after the first digit. So that's perfect. Great. Now, the question is, what am I going to do with the tens and their powers?
Subtract?
Right, exactly. And in case you're unclear, let me just give the reason, because again, math is not just memorizing rules, but patterns. Yeah, suppose you had like 10 to the 5th over 10 to the 2nd. Just think about what you would do. What does 10 to the 5th mean? Well, we all know that means 5 tens, right? And what does 10 to the 2nd mean? 2 tens. And we know we can cancel things in fractions, right? So what are you left with? 3 tens. So what would be the shortcut? Just take 5 minus 2. Just subtract the powers. So again, I'm just proving what you guys already have observed to be true. That if you're dividing tens to powers, you should subtract the powers, right? That's the shortcut. That's the quick way. We don't want to write all this out every time, do we? We want to just subtract those powers, jump right to the answer. Is that good? Whereas like over here on this last one, oops, sorry, down here on this last one, we were multiplying. So when you multiply tens with powers, you add them. You add the powers, right? So when you multiply tens with powers, you add the powers. But when you divide tens with powers, we're dividing here, you subtract the powers. Exactly. So let's do it. So are you ready? We've got 10 to the 5th over 10 to the minus, but let me write it over here. 10 to the 5th over 10 to the minus 4. Subtract the powers, what do we get? 10 to the 1. Is that good? 5 minus 4. Subtract those powers. No, that's wrong and crazy. But it's not crazy, but it's wrong. And I see that mistake all the time, so that's why I'm doing it. That's wrong. That's not correct. I'm doing what's wrong so that you will not do what's wrong. Why is that wrong? How's that wrong?
Because wouldn't it be if you set up the equation and then 10 over -4? So when then you write it out, wouldn't it be 5 minus parentheses minus 4 parentheses?
Yeah, exactly. Good. Yeah, I didn't really subtract the powers, did I? It's got to be 5 minus 4. Exactly. Good job. You've got to take the power on the top minus the power on the bottom. And if the one on the bottom is negative, then you're going to have the double negative thing, and it's going to be 5 plus 4. It's actually going to be 10 to the 9th. Right. Everybody see that? So it's a really common mistake to make, to accidentally forget that you're subtracting a negative, so you're actually going to add. You see, if it was 10 to the 5 over 10 to the regular 4, yeah, that would be 10 to the 1. But if you have 10 to the 5 over 10 to the -4, that's going to actually come out 10 to the 9th. See the difference? In this case, you're subtracting a -4, 5 minus -4, whereas here it's just 5 minus 4. Right? So watch out for that. Really easy mistake to make. So this is 10 to the 9th, and we're done with this problem. So what did we do? We divided the numbers in the front. We subtracted the powers. But be careful when you subtract a negative, that's actually adding. And so we got it right eventually.